Good morning, students. Today we are going to discuss chapter 2, acids, bases and salts. First of all, we are trying to understand what do these terms actually mean in terms of chemistry. Acids are substances that form hydrogen ions when dissolved in water. In this category, we can place substances like hydrochloric acid, sulfuric acid, nitric acid, etc. Hydrochloric acid, when dissolved in water, result in production of hydrogen and chloride ions. Nitric acid, dissolved in water, result in formation of hydrogen and nitrate ions. So the common ions in these two substances are hydrogen ions. It is these hydrogen ions which are actually responsible for acidic nature of a substance. Then the next category is of bases. These are actually oxides and hydroxides of metals which react and neutralize acids to form salt and water. And the bases which are soluble in water are called as alkalis. In terms of a layman, we can say bases are those substances which furnish or which produce or which form hydroxyl ions or hydroxide ions when put in water or when dissolved in water. In this category, those substances which are soluble in water among bases are called as alkalis. The common bases which you come across in your daily diets are sodium hydroxide, calcium hydroxide, etc. Sodium hydroxide, when dissolved in water, forms sodium and hydroxide ions. Similarly, calcium hydroxide, when dissolved in water, give calcium and hydroxide ions. So the common ions which are present in these two substances are hydroxide ions, or which you call as hydroxyl ions. These are basically responsible for their basic nature. So in summation, we can say that acids give hydrogen ions in water and bases give hydroxide or hydroxyl ions in water. In acids, there are more hydrogen ions as compared to hydroxyl ions. In alkalis or alkaline solution, there are more hydroxyl ions than hydrogen ions. We need to know this because the question is generally asked, do you think that bases contain hydrogen ions? If yes, then why are they termed as bases and not acids? In context to this question, these two terms are compared here in terms of ions. We say bases do contain hydrogen ions, but the number of hydrogen ions compared to the number of hydroxyl ions or hydroxide ions are much less. That is why they are called as bases or alkalis. Alkalis are bases which are soluble in water. Then further, they have given us the distinction between strong acids and weak acids. Acids that dissociate or ionize or break into ions on dissolution in water to a large extent are called as strong electrolytes or strong acids, means they furnish large amount of hydrogen ions in solution. And acids which dissociate or furnish these hydrogen ions to a small extent in solution, that is in water, they are called as weak acids. Since they are weak acids, they are weak electrolytes. Similarly, strong acids are strong electrolytes. Depending on the concentration of ions, again we can divide bases also into two categories, that is strong bases and weak bases. Strong bases are those which furnish large amount of hydroxide ions in solution, and weak bases are those which furnish comparatively very less amount of hydroxyl ions in solution. So thus, on the basis of the number of ions given, we can identify a substance, whether acid or base, as strong and weak. Now next they have given us the basicity of acids. Basicity of acid is actually the number of ionizable hydrogen ions present in an acid. Let us take example of hydrochloric acid. In solution, it is capable of giving only one hydrogen ions. That is why we say hydrochloric acid has basicity 1 and it is monobasic in nature. Next we come across sulfuric acid, H2SO4, which gives 2 hydrogen ions in solution, and that is why we call it as dibasic acid. Next is phosphoric acid, H3PO4. In solution or in water, it is capable of forming 3 hydrogen ions, thus we call it a tribasic acid. So basicity of acids is determined in terms of the number of hydrogen ions which an acid is capable of giving or furnishing in water or in solution. Next we come across acidity of a base. It is actually the number of ionizable hydroxyl ions present in an alkali. The very first example given is of sodium hydroxide. It gives sodium and hydroxyl ions in solution. Similarly, calcium hydroxide, it gives again calcium and hydroxyl ions in solution. We call sodium hydroxide as a monoacidic base because it gives 1 hydroxyl ion in solution. Similarly, if we talk of calcium hydroxide, it gives 2 hydroxyl ions in solution. That is why we call it as diacidic base. So this is about acidity of a base. Now summation of properties of bases. Bases react with fats to form soap and glycerol, and this process is called as saponification. This you will study in practical related to the chapter in later part. Then bases have pH more than 7. What is pH? We'll come across in the later part of the chapter. Then dilute solutions of bases taste bitter. Bases turn phenolphthalein pink, litmus blue, and bromothymol blue to blue. So these all are actually the indicators which you have read in your earlier classes. Bases neutralize acid, and this process of neutralization is called as neutralization. Bases are formed when alkali metals or alkaline earth metals react with water. When we say alkali metals, it refers to metals which are present in group 1 of the periodic table, and alkaline earth metals which refer to group 2 in the periodic table. The words alkali and alkaline mean basic, and they are this is a contrasting term in reference to acids. Then next come the physical properties of acids and bases. Let us see. Acids taste sour. Acids are harmful to living cells as they have corrosive action on skin. Then aqueous solutions of all acids contain hydrogen ions. This we have already seen how they ionize in solution to form hydrogen ions. Acids turn blue, litmus red. Then strong acids are corrosive in nature. Now let us see the properties of bases. When we come across properties of bases, we can say alkalis or bases taste bitter. Strong alkalis also have corrosive action on skin. Aqueous solution of all alkalis contain hydroxide ions. Alkalis turn red litmus blue, and alkalis are soapy to touch. So these all represent the physical properties of acids and bases. Next, we come across the chemical properties of acids and bases. And when we talk about chemical properties of acids and bases, basically we refer to the reaction of acids and bases with different substances. Like the very first example which is shown here, that is chemical properties of acids, and we have in this category, when we talk of chemical properties of acid, the reaction of acids with metals. Let us see. Metals which are above copper in the reactivity series of metals react with acids to give hydrogen gas, and we can detect the formation of this gas by means of a burning splinter, which gives a faint hot sound due to evolution of hydrogen. This is the confirmatory test for gas hydrogen, which is evolved here. And if we react bases with acids, like we know bases are generally metal oxides and metal hydroxides. So when these bases react with acid, the result in formation of salt and water. As we have already read, acid reacts with base to give a neutralization reaction, giving salt and water, and in this reaction, along with salt and water, heat is also produced. So we can say this reaction is exothermic in nature. In this slide you are seeing the reaction of copper oxide with sulfuric acid. Copper oxide is a base, sulfuric acid and acid. They react together to give copper sulfate, which is salt, along with water. Now, next reaction which they have given of acids is with metal carbonates. With metal carbonates, we see that acids react with metal carbonates to result in formation of basically carbon dioxide gas. So as soon as you add acid to any metal carbonate, we see that effervescence occurs, and along with it a gas is produced. When we try to identify this gas, we use lime water. This lime water actually turns milky with this gas form, as we are able to identify that the gas formed is carbon dioxide, because the distinguishing test for carbon dioxide gas is that it reacts with lime water and thus turns it milky. And this milkiness is due to formation of white substance, which is called as calcium carbonate. So these are some of the chemical properties of acids. First was with metals, second was with bases, and third was with metal carbonates. They all are referred to as chemical properties because in all these cases chemical change is taking place. That is, when we say chemical change is taking place, that is, a new substance is formed after the reactants react with each other. So these are the chemical properties. Now next we come to the neutralization, which is actually reaction between acid and base to form salt and water. The type of reaction taking place is double displacement. Double displacement is a type of reaction where two substances react with each other and interchange their metallic and non-metallic parts, or acidic and basic parts, or cations and anions. When they will exchange their cations and anions, or acidic and basic parts, two new substances will be formed. So same is the case here. Let us take the example which is shown here of hydrochloric acid reacting with sodium hydroxide. In hydrochloric acid, the cation is hydrogen and anion is chloride. Similarly, in sodium hydroxide, the cation is sodium and the anion is hydroxide. So when they exchange their cations and anions, the substance formed will be sodium chloride. From HCl we have taken chlorine, and from sodium hydroxide we have taken sodium. So the substance formed is sodium chloride, and along with it water will be formed. So these are examples of neutralization, and this type of reaction is called as double displacement. Here it is also written, the word is replaced, displacement is replaced by replacement. The better word is displacement, double displacement, or we can also call it double decomposition reaction. Replacement word is used here to make you understand actually how the reaction is taking place. At times the children are confused that what do we mean by displacement. So in order to simplify this word, they have used the term replacement to make you understand better. Now next we see how hydronium ion is formed. Children, you all know when acids are placed in water, they result in formation of hydrogen ions. Now these hydrogen ions are not capable of independent existence in aqueous solutions. So what do they actually do? They combine with water molecules to give more stable ions, which are called as hydronium ions. If you see this slide carefully, you are seeing that hydronium ion is represented by the symbol H3O+. Now how this is formed? When hydrochloric acid is placed in water, it first forms hydrogen ions and chloride ions. These hydrogen ions combine with water molecule to form hydronium ion, which is comparatively stable as compared to hydrogen ions. So we all know, we had just now read the basicity of acids, that different acids yield different number of hydrogen ions in solution. So accordingly, the hydronium ions will be formed. Here they have shown two more examples of sulfuric acid and phosphoric acid, just to make you understand that in sulfuric acid, you see the reaction is shown in two steps. In one case, bisulfate ion HSO4 is formed when there is partial replacement of hydrogen, and in the second case you see sulfate ion SO4 2- ion is formed when there is complete replacement of hydrogen, because the basicity of sulfuric acid is 2. So in one case there will be partial replacement of hydrogen, and in the other case there will be complete replacement of hydrogen. Now let us see this slide, which actually identifies some uses of acids, that is the applications in our daily lives. We all know HCl is found in stomach. It helps in digestion of food. Then sulfuric acid is present in car batteries as drying agent. Then nitric acid is used in manufacture of fertilizers. Similarly, ethanoic acid is used in food industry. Ethanoic acid is basically actually which acid you think? It is acetic acid, which is used for preservation. Then we use fatty acids for soap making. Then ascorbic acid is used in preparation of medicines. So we can say in different walks of life we use acids, and thus they are an important part of our life. Now some chemical properties of bases. First is neutralization. I am not going to go in details of neutralization because you already know it well, we have already done it. Then please see the example which they are trying to tell us here. Ammonium salts are decomposed when mixed with a base like sodium hydroxide. Ammonia is readily detected by its strong smell, that is pungent odor, and by turning damp red litmus blue. How we can identify this? By litmus paper, which will be turned from red to blue. This helps us to identify its basic nature. The reaction which is shown here, ammonia gas is formed, and this ammonia gas actually is basic in nature, which can be detected by litmus paper turning from red to blue. This reaction is actually used to prepare ammonia gas as a test for ammonium salt. We are discussing in detail ammonium salt here specifically because ammonium hydroxide is an important base. Now, further properties of bases, chemical properties. Alkalis are used to produce insoluble hydroxides, and since these hydroxides are insoluble, we call them as precipitates. And the reaction which is shown here, sodium hydroxide undergoing reaction with copper sulfate, it actually forms sodium sulfate and copper hydroxide. Copper hydroxide is appearing here in the solution in the form of precipitate. When we say precipitate, precipitate means insoluble solid which is formed in the solution. So this reaction actually is a simple test to identify certain metal ions and can also be referred to as a precipitation reaction. Then oxides and their types, important part of the chapter because the question is coming on this portion of the chapter generally. Basic oxides, actually they are telling the position in the periodic table. We will not go into the details of periodic table here. We will just try to understand these metallic oxides which are named here: sodium oxide, magnesium oxide and copper oxide. These are actually basic oxides as they are metallic oxides, and we know metallic oxides generally are basic in nature. So when they are basic in nature, they are bases. When they react with acids, what will they form? Definitely salt and water. So this property of basic oxides is very well indicated by this reaction, that these oxides react with acid to form in salt and water, and thus they are forming salt and water, so definitely these oxides are basic in nature. Next is acidic oxides. Acidic oxides are generally the non-metallic oxides. This is clearly shown by this example. Sulfur dioxide reacts with water to form sulfuric acid. Sulfur dioxide is a non-metallic oxide. It dissolves in water to form sulfurous acid. Similarly, sulfur trioxide dissolves in water to form sulfuric acid. So this indicates that when they dissolve in water to form acids, these non-metallic oxides are actually acidic oxides. Next in category comes the amphoteric oxides, very important part of the chapter. These are actually few metallic oxides which can react both with acids as well as with alkalis. So specific feature of amphoteric oxide is that it can react both with acids as well as alkalis. They are usually relatively insoluble and have little effect on indicators. Example in this category is aluminium oxide, which reacts both with acid and base. When it will react with acid, it will form aluminium salt, and when it will react with base, it will form aluminate salt. So in both the categories, whether reaction with acid or reaction with base, it will form salt. Then another type of oxide is neutral oxides. They are again non-metallic oxides. Few non-metallic oxides are neutral in nature. They have comparatively less solubility in water and do not affect the litmus. They do not react with acids or alkalis. Example in this category is CO, that is carbon monoxide, and NO, that is nitrogen monoxide, and water. Then we have salts. We have discussed about acids and bases in detail. Now we have to see salts in detail. When hydrogen ion of an acid is replaced by a metal ion, salt is produced. Let us see the example. Sodium hydroxide reacts with sulfuric acid to form salt sodium sulfate. Along with it, water is produced. Similarly, ammonia reacts with nitric acid to form ammonium salts. Like in this case, ammonium nitrate is formed. So ammonia is also a base. Then methods of making soluble salts. There are few basic methods, the general methods which we have to remember. Acids react with metal to form salt and hydrogen. Acid react with base to form salt and water, that is neutralization reaction. Acids react with metal carbonates to form salt, water and carbon dioxide. Similarly, acids react with alkalis, that is soluble bases. Alkalis are soluble bases to form salt and water. Then direct combination also salts can be formed. For example, sodium reacts with chlorine to form sodium chloride. This is an example of direct combination. Like acid react with metal, they have given us here two examples. Zinc react with hydrochloric acid to form zinc chloride and hydrogen. Zinc chloride is a salt. Iron reacts with sulfuric acid to form iron sulfate. Iron sulfate is a salt. Then reaction of acid and base, again they have given two examples, copper oxide and sulfuric acid forming copper sulfate, that is a salt. Magnesium oxide reacting with hydrochloric acid forming magnesium chloride, which is again a salt. So here they are given examples of two categories, metal with acid and acid with base. Both cases, salt is one of the common products. Next is the third method of preparing salts, that is acid reacting with carbonate. Example given here, calcium carbonate reacting with hydrochloric acid to form calcium chloride, which is salt. Sodium carbonate reacting with sulfuric acid to form sodium sulfate, which is a salt. Then acid reacting with soluble bases, that is alkalis. Sodium hydroxide is an alkali. It reacts with acid to form sodium chloride and water. Then ammonium hydroxide is again alkali. It reacts with sulfuric acid to form ammonium sulfate, which is again a salt. Now, next reaction, the important category of precipitation reactions. These are the salts formed which are insoluble salts. Means they are appearing in the solution in the form of precipitates, that is insoluble solids. This involves mixing solutions of two soluble salts that between them contain the ions that make up the insoluble salts. First one is precipitation reaction, where you have the salt in the form of precipitate. Like here, barium chloride is combining with magnesium sulfate. Both are soluble salt solutions. They react with each other to form barium sulfate, which is insoluble salt, that is, which appears in the solution in the form of precipitate. Next is direct combination, where iron reacts with sulfur. Two elements react with each other, like iron reacting with sulfur, metal, iron reacting with non-metal sulfur to form iron sulfide, and iron sulfide here is insoluble salt. Next, they have shown us how precipitation reaction takes place. You are seeing in the first image the yellow precipitate appearing in the solution, and similarly in the second case the white precipitate appearing in the solution, and they have shown how the particles combine with each other when the new substance is formed. Now next is the types of salts, different categories of salts. First is the normal salts, which are formed when all the replaceable hydrogen ions in the acid have been replaced by metallic ions, like sodium hydroxide reacting with hydrochloric acid to form sodium chloride. Sodium chloride here is normal salt. Why we call it a normal salt? Because HCl has only one replaceable hydrogen. This one replaceable hydrogen of HCl is replaced by or exchanged by sodium. So HCl, in HCl, H is replaced by Na. So the product formed is NaCl. So all the replaceable hydrogen of acid are replaced by metal ion. That is why example of normal salt. Next we have acid salts, where all the replaceable hydrogen ions present in acid are not replaced at once. They are only partially replaced. For example, let us see, sulfuric acid is reacting with potassium hydroxide KOH. sulfuric acid has two replaceable hydrogen ions. But in this reaction, what is happening? Out of two, only one is replaced by metal, that is K, metal ion K. So we have product KHSO4. Hydrogen is still there in the salt. So this is partial replacement of hydrogen from acid. And that is why we have formation of potassium hydrogen sulfate, which is actually acid salt. So all the hydrogen ions which are present are not replaced